Energy is the bedrock of a prosperous society. All the products we use and all the building materials, everything, transportation of products around the world, all of that requires energy. And you can look up for different types of products. You can look up how much of that product's price is the energy price. In some cases, 80 or 90% of the product's price is the energy behind it. In other cases, maybe it's only 10%, but almost all products have a fairly big share of energy in their, it takes energy to make products and transport them and so on. And of course, you also use energy for heating your house, cooking your food, light in your house. And we use a lot of energy for recycling of products and so on.
Welcome to Sustainability Transformations podcast, where we explore bold ideas to drive positive change for people, the community, and business. Today's guest is an inventor, energy futurist, reactor pioneer, systems thinker, and global problem solver. Thomas Jam is the CEO and co-founder of Copenhagen Atomics, pushing the boundaries of clear, scalable, affordable energy from thorium, molten salt, reactor technology. If you are ever wondered what the future of energy might really look like, this conversation is unmissable. And the goal of our conversation is exploring thorium waste and the future of cheap, clean energy. Thomas, thank you so much for joining us. Can you introduce yourself to the audience and how you went from IT to nuclear energy?
Yes, thank you very much. Yes, it's true. Originally, I got a degree in engineering, but not nuclear engineering. This is, of course, many years ago, back in the 90s. But I studied both in Denmark, engineering both in Denmark, but also in the US, in Texas in the US. Anyways, then I went about my career for many years doing mathematical modeling, simulations, a lot of software development. Back then, you had to write all the code yourself. Now, today, you can get the AI to write your code. But and because of this, I worked with energy systems. I got involved in simulating things around nuclear energy. And me and 3 other people decided to start a company called Thorium, called Copenhagen Atomics. The reason we started the company is because we saw that there was a possibility to make a new type of nuclear reactors that could be much more efficient than the traditional nuclear reactors we have. Today, we have 400 nuclear reactors in the world that produce electricity, but we realized that we could make probably energy much lower cost, but more importantly, that these new type of reactors could be installed much faster. So yeah, what's not to like if you can get low cost energy and get to just install it really fast. So the idea with our type of reactors or our company is to mass manufacture reactors. We want to make at least one nuclear reactor every day. They come in sort of the form factor of a 40-foot shipping container. That's roughly the size of a commercial reactor. And then we can install many of those at the same site. Right now, it's not possible because of the regulations around nuclear. It's not possible to install one in your house or your on your ship or something. You still have to install a number of these at a site that is nuclear approved as a power plant. Maybe later, 20 years from now, maybe it's possible to install one at each big factory or something like that. But this was a sort of a very quick introduction to myself and the company.
Yeah. So you've said energy is the most important factor for future prosperity. Why is that?
Yeah, so energy is sort of the bedrock of a prosperous society. All the products we use and all the building materials, everything, transportation of products around the world, all of that requires energy. And you can look up for different types of products. You can look up how much of that product's price is the energy price. In some cases, 80 or 90% of the product's price is the energy behind it. In other cases, maybe it's only 10%, but almost all products have a fairly big share of energy in their, it takes energy to make products and transport them and so on. And of course, you also use energy for heating your house, cooking your food, light in your house. And we use a lot of energy for recycling of products and so on. So, I mean, if you want to make, for example, wind turbines or solar cells, you need a lot of materials for that. And those materials takes a lot of energy. For example, solar cells, you need silicon plates and you need aluminum. And both of those are very high intensity energy consuming materials. So for a solar cell, the solar cell might live for 10 or 15 years. And in that whole lifetime of the solar cell, it produces maybe 2 or 3 times more energy than what was required to build those solar cells in the first place. And that's, of course, because all that aluminum and silicon needs a lot of energy. And it's a similar thing with the wind turbines and so on that. So energy is a big part of a prosperous society, and having access to products. You can think about any product you've ever seen. It's probably produced in some sort of house or factory. And those factories are made of concrete and steel and other materials. And especially concrete and steel uses huge amount of energy to be manufactured from when we dig it out of the ground and refine it and get it to a steel product. And then today, actually, 60% of all steel in the whole world is produced in China, and 70% of all aluminum in the world is produced in China. And that's because they have access to low cost energy. When I was a kid, the European Union was actually called the Coal and Steel Union. And we used to make a lot of steel in Europe, but now it's Europe can no longer compete with the low prices from other parts of the world. And that's because energy is expensive in Europe. And the last 5 years, it's gotten very expensive compared to other places in the world. So that's part of what we want to change. We want to give all people, not only in Europe, but all over the world, access to low-cost energy. And we need lots of energy. In the last 100 years, the energy consumption of the whole world has increased tenfold. And we expect also in the next 100 years that the energy consumption will again increase tenfold from where we are today. So that's a lot of energy. It's a huge amount. And it's difficult to, when you start looking at where can we get all that energy from? Is there enough hydropower? Is there enough wind or solar? Is there enough, coal, oil, and gas, or nuclear? It starts to become difficult because some of those sources I mentioned is definitely not going to scale very much further. Maybe some of the other ones can scale, and nuclear energy, especially the one we work with, the thorium type of nuclear reactors, is the one that has the highest potential of scaling. And I believe, I've said before that I believe by year 2100, that half of all energy in the world will be made from thorium. So that's in 75 years from now. And today we don't actually use thorium for energy. So it's going to be a big transition. And we as a company are part of that transition.
Very curious question. If the energy is going to increase tenfold from now, then why is it called energy transition? Because we are not actually transitioning, trying to hopefully challenge the premise of the word energy transition, because it is energy growing. Because if it's transition, then it's like you are going from say 100% fossil fuel and you are transitioning to nuclear. But here's a case where it's going to grow 10 times, then could their understanding of the policy leaders, business leaders shift from that transition?
Yes. Yeah, there's also this whole political discussion going on, and I don't want to be a big part of that, but there's some part of the globalist movement that want us to be less people in the world, and we should use less energy, and less energy obviously means less prosperity. So there's some people who have a different agenda, and they actually have a lot of supporters in Europe, but you can see already that in Asia, including India, but also in the US now, that people are leaving that agenda more and more, and they want to live a prosperous life. There's also another movement saying that the net zero story of energy and the climate change story is a hoax. I mean, so there are different political fractions that have a different vision of where the world is going. I'm not too big of a participant in that whole debate, but we are a company producing a new type of energy solution that can generate energy at a very low cost, and we get a lot of lots of countries and people contact us and are very interested in being able to buy energy at low cost. Our target price is $20 per megawatt hour, which is roughly 4 times lower price than for traditional nuclear energy. For example, you are located right now in the UK. The nuclear energy prices there are quite high, and especially now that the UK is building some new reactors, the Hinkley Point C and the Sizewell C and so on. I think those are the energy prices above 100 euros or $100 per megawatt hour. And we want to target $20 per megawatt hour. And I know that there's a lot of countries who wants to get access to that and grow their energy portfolio. And of course, our type of energy, thorium energy, is a green form of energy. It doesn't release any CO2. So in that sense, many people think it's better than fossil fuels. But my belief is that even 100 years from now, we're still going to use both fossil fuels and hydropower and nuclear and wind and solar and I mean, all the different types of energy sources we have today. And thorium energy is just one of the new energy sources on that stage or global stage. And of course, being from a company developing this technology, I have really high hopes for thorium. And I think it's going to take a very large market share of the global energy market. And especially for things like aluminum production, ammonia production, and data centers. There's a lot of hype right now around data centers and AI that they need a lot of energy. For example, Elon Musk came out and said that he wanted to build 1 terawatt of compute, which is so what he's suggesting is that his data centers will use twice as much electricity as all of the USA uses today. So all other companies and private homes and factories and businesses and the military in the US today, he wants to use twice as much energy as that just for AI computers. And I don't think it's unrealistic. I think it's going to happen, but of course it's going to take him more than 10 years to build that out. And we also see other stories where people want to, of course, many people want more electrical cars in the world, and electrical cars require a lot of energy to build. They use 3 or 4 times more energy to build an electrical car than to build a traditional gasoline car. And all that energy is going to come from somewhere, and usually it comes from China because the batteries, the lithium and the aluminum for the cars are made in China. And China makes all that aluminum today from coal. They would like to change that. They would like to use a cheaper form of energy, for example, thorium. And China actually has a lot of thorium in stockpile. China and India are the countries in the world that has the largest amount of thorium in stockpile. So it's likely that those two countries will install a lot of thorium energy. And I mean, because of aluminum and lithium and these other things use so much energy, they can easily double. Those countries can double the global amount of energy we use today if they want to transition away from coal and want to make more aluminum for electrical cars and more data centers. Actually, also when you look at data centers, the computer chips themselves are made from silicon. That require quite a lot of energy to make those, but all the racks and everything in the data center is made from aluminum. So you use a lot of aluminum in a data center, and all the cables are made from copper. Copper is also quite energy intensive when you want to make that. So yeah, so if we want, electrical vehicles and data centers and AI, we're going to use a lot of energy to manufacture all of that and install it. And that's where we come into the picture.
Just to give an idea of size, I know you've mentioned about the cost in terms of size of household or business can use your thorium energy systems so the viewers can picture what type of household sizes and business sizes.
Yes, so I mentioned a little bit earlier the reactor itself that we built is roughly the size of a 40-foot shipping container, so you can transport it on a regular lorry. That means it's roughly 12 meters long and 3 meters wide and 3 meters high. But that's only the reactor unit. It needs to sit inside a building, and because of the nuclear regulations in most countries right now, you basically need to install many of these at the same site. So if you have an aluminum factory, for example, you might install 20 or 50 of these units on the same site. And the building where you install all these reactor units inside can easily be 500 meters long building, and then it would be 50 or 70 meters wide and 10 meters tall. So it looks a little bit like a normal distribution center, like an Amazon distribution center or maybe a Walmart shopping center, something like that. So it doesn't look like a traditional nuclear power plant. It looks more like a industrial building. And then, if you have a really big site where you make ammonia or something like that, then you might install more than 100. So then you would have several buildings at that site to generate the energy. Maybe I should mention for the audience, because a lot of people don't know the role of ammonia. So today, the global ammonia market is 200 million tons per year, and it's made from natural gas. Sort of 99% of it is made from natural gas. But we want to change away from natural gas and use something that is not fossil fuels. In that case, you can use thorium energy from our reactors, and then you take seawater and you split that into hydrogen and oxygen with electrolysis, similar to what many people have done in their physics class in primary school. And then once you have that hydrogen, you use that and mix it with nitrogen from the air, and then you get ammonia. Ammonia is a fertilizer foremost. It actually fertilizers. When you have fertilizers, half of all the food in the world is produced from fertilizer. Or put it in another other way, if you didn't have fertilizer, we could only produce half as much food in the whole world in the same amount of land that we use for producing food today. So you can say when you go into your supermarket and look at all the food on all the shelves, half of the energy in all that food comes from ammonia. And ammonia is made in factories, and the energy in those factories come from natural gas. But that's what we as a company would like to change. We would like that energy to come from thorium instead. I mean, the food will taste the same, of course, and it will look the same. But instead, the half of the energy in the food would come from a green source instead of a fossil fuel source. And of course, this is going to take 20 years to sort of transition that industry. Again, today, the big producers of ammonia in the world are India and China and the USA and Russia. We used to make ammonia in Europe, but it has declined a lot because our energy is too expensive. So we cannot afford to make ammonia in Europe. We buy it from these other countries. Because we still need the food, and we still have farmers in Europe that produce food. Actually, you saw that there was a lot of strikes or a lot of demonstrations from farmers about half a year or 1 year ago. And this was all about the new rules and the new regulations around fertilizer and ammonia. Now that we talk about ammonia, I want to mention one more thing. Ammonia can also be used in the chemical industries for generating hydrogen in the chemical industries. Today, a lot of times in the chemical industries, we use, again, natural gas. But as we want to move away from that, or if we want to make more chemicals for more products, more people in the world who wants to have great products, we need to use additional energy to generate that hydrogen. And that can be done from thorium reactors and from ammonia and electrolyzers like I was talking about before. A lot of times you make the ammonia in one factory, and then you transport that ammonia over to the chemical factory, and then the chemical factory uses that ammonia for getting the hydrogen. And ammonia can also be used as a replacement fuel for diesel oil in trucks and ships and trains and so on. So we expect that half of all the ships in the world that sail on the oceans, that transport all our goods from either the raw materials from the mines, transport that around, or they transport the finished goods like shoes and iPhones and so on from China to Europe. Those ships in the future can sail on ammonia as a fuel instead of diesel oil. So there's going to be a lot of transition from one type of energy source over to new types of energy sources. And Copenhagen Atomics and our thorium reactors is going to be a big part of that. It's not something that normal people see in their everyday lives, because it's when people go to work and they use the metro or the bus or the car or whatever, they don't see that we are one of the companies behind that, powering everything from making the aluminum in their car or generating the electricity for the metro or the electrical vehicle, or making the steel or the concrete for all the buildings and the bridges and so on. But that's what we are all about, and it's a big part of the world economy to make all this energy. And like you said, it used to be, or even today it's still 80% of all energy in the world is made from fossil fuels. And this is going to change. And I think in the past, there was some people who thought that we were going to reduce the amount of energy we use. But my opinion is that we will increase the energy tenfold over the next 100 years, and all that new energy will be a different type of energy. It will be wind and solar and thorium energy, and to some extent hydropower. We already use hydropower today, and there's not much more hydropower we can get, but maybe a little bit more in some places.
Yeah, that's good. So one container of that energy, I'm simplifying here for the audience. One container can power 10 homes, 100 homes, would you say?
One container can power, depending on what country, how much energy they use, but between 20,000 to 50,000 homes. That's because
Wow.
homes doesn't use that much energy for cooking your food or having light in your home. doesn't require that much energy. But of course, if you have air conditioning or if you have a heat pump, that requires more electricity. Or if you have an electrical car that you charge at your home every day, that also requires more electricity. So it depends a lot on where you live in the world and what kind of appliances you plug into the grid. But of course, if you think of yourself as a person, less than 10% of the energy you use is in your home. 90% of the energy you consume as a person is from all the products you consume. I mean, the producing all those products, making all the factories for all those products, transporting all those products around in ships and making bridges and all that good stuff, and hospitals and stuff, that uses a lot more energy. So roughly 90% of your energy is outside the home, and 10% of your energy consumption is inside the home.
Different parts of the world have different energy intensity. That the embodied energy, if I could use that term, in different products. Why is that it's not a common knowledge where the energy understanding tends to be more what we use physically in the air conditioning or the lighting and so on? Why is that less popular knowledge?
Yeah, my background is in engineering, and I actually, I went through the school system in Denmark, and part of the time I also went through the school system in the USA, and we learned very little about energy in primary school, very little. High school maybe a little bit, but not a full understanding. And then I studied engineering, and we learned quite a lot about energy, but they just taught us about the physics and the calculations or the formulas for energy. They didn't teach us about how everything is made. And that's something I had to learn on my own. And in our company, we actually spent quite a bit of time teaching our employees about that, because also they never learned it about it anywhere. And our business leaders, if you go to business school, or if you're politicians or journalists, you never learn about this anywhere. And there's a lot of good new YouTube videos about it, and of course also this podcast. But so it's starting to become more available. But in the past there was not a lot of focus on this. Of course, the oil industry, oil and gas, they had executives who learned about it, but it was not super common knowledge in the past. And I think there's maybe a whole generation of people who was born in the 80s and 90s and in after the 2000s who never really learned about it. And I would say that the traditional media, like traditional TV shows, have some of the blame, because they never really explained this in a way where people can understand it. And so people have no idea how things are made and where the energy is coming from and how much energy is required for EVs and aluminum and chips and so on. But now with the AIs, with the Chat GPT and Grok and other things like that, you can actually ask it questions about that. They are fairly good at answering those questions correctly and giving you sort of the right proportions of how much energy goes to this and that. But I would say that the people in charge of the energy politics in Europe are very misinformed about energy. And maybe it's not their fault, because they never learned about it and they just wanted to be a politician. And unfortunately, they didn't spend the time to read up on this themselves. So yeah, they tend to say things that are ridiculous sometimes. But the world is not perfect. We still have to make it work.
Absolutely, which explains why, for example, there might be a lot of focus on a plastic straw, where those who are being drawn to the plastic straw, they want to eliminate fossil fuel from their lives, but they probably don't realize that the cup may be made of paper, but the processing of that paper has so much energy in that, perhaps the plastic, as an example, just picking something which is common. The energy transition, I think the initial question I asked perhaps sounded more like the political side, but I think between 2020 and 2022, there was a pandemic. It gave people enough time to actually realize that the climate change impact could be a significant challenge that humanity have to focus on. And this is my observation. But as soon as 2022 to 23 GPT and AI came, all of a sudden, that sense of urgency around climate change and sustainability. And I say that because you have Larry Fink, the CEO of BlackRock, and other key CEOs and influential leaders were talking about how essential we have to deal with the climate change impacts and so on. But I believe, looking at just the next 5 years, you used the example from the Elon Musk, how much energy is going to be consumed. There is some estimate that just in 5 years from now, by 2030, 15 to 20 trillion dollars of investment in AI is going to come in. So I guess the question is, or the observation is, the amount of energy needed to meet this AI is so huge that the current fossil fuel and solar isn't going to be enough to meet those demands. And that's where I personally see the nuclear energy coming in. And again, having this discussion is to understand what type of nuclear you produce. Is that a fair assessment at the very end of how much demand this AI needs? And that's where I believe there is. It's not only in only AI, but if I look at one aspect of the AI, the amount of energy hungry is the term I've heard being used. It's very hungry for energy. I know you've mentioned on that, but I thought I would tease out a bit more around that area.
Yes. Yeah. So there's a lot of economical pull and push in AI right now, and the chip factories. It takes many years to make the chip factories, and they have already gotten orders for sort of the chips that they are going to make in the next 3, 4, 5 years, and they are now building new factories for that. So we already know from that how many chips are going to be made before 2030, because they cannot suddenly make more of it. It takes many years to build the factories. And those chips that they will make until 2030, to power those chips in data centers require roughly 100 gigawatts of electricity. And 100 gigawatts of electricity is sort of 1/3, roughly, of all the electricity that we generate in Europe. In America, they generate a little bit more electricity because it's not as expensive, and they use air condition more, and so on. But so in the US, that electricity alone for the data centers is going to increase the total amount of electricity in the US by 30%, something like that. And so you can see that is a significant increase, and it's definitely a bigger growth in electricity than what we've seen in the past decades. So the total amount of electricity production in the US will grow, but this is just until 2030. People are also looking at what's going to happen from 2030 to 2040 and even further on. And then it will be much more energy. I mean, when we get to something like it's somewhere between 2040 and 2050, AI alone will use more energy in the US than everything else uses today. And that's back to the story I said about Elon Musk wanting to install 1 terawatt of compute, which is twice as much as what the total US market consumes today. Yeah, so the AI is driving the growth in electricity, but I also mentioned that aluminum and ammonia and other products is also going to drive that growth. Maybe not so much in Europe because our energy is too expensive, but in places like India and China. And I would really like to see Africa also take off, because there's a lot of people in Africa contacting us as a company all the time and asking, can we, you tell us that this is cheap energy, can we buy that? And they will be able to buy that. Maybe not from day one, but we definitely want to sell our form of energy and install that in Africa. And in this, our type of energy with these reactors are actually very well suited for the type of electricity grid that is in many African countries. So it's maybe better than a large traditional nuclear power plant or a hydropower plant or big coal-fired power plant. But let's see where everything goes. But I hope that we can install sort of 25% of all the energy we create in Africa, because it is a big continent, and it's a fast-growing continent. I forget the numbers right now, but I think there's roughly 1 billion people now, but they expect that there will be 4 billion people in Africa by maybe that was by 2070. I can't remember the exact year. Is it possible for me to share a slide on this?
Yeah, sure. Yeah, you can share a slide.
Because you mentioned the pandemic, and I just want to show this slide here.
Yeah, sure.
So this slide here tells
Yeah.
us how much energy the whole world has consumed in the last 200 years. And you can see here, there was a small dip here in the 1970s, and that was because of the energy crisis in the 1970s, or I think it was called the oil crisis. And then here in 2009, when we had the economic crisis, there's another little dip. And then again, when we had the pandemic, you spoke about the pandemic, we have another little dip. So this tells you how the whole world, how much energy the whole world uses, and also tells you whenever there is a crisis in the media, when the media talks about a crisis, this only creates a tiny dip in the chart. And of course, people like me and other people believe that this chart will just keep on going up and going up even steeper than what it is right now. I also want to tell the audience about a lot of times in European politics and European media, we talk about these energy sources up here. So renewable and wind and solar and hydropower. Those are the ones we talk about. But we forget about all this down here, like the 80% of the energy in the world. And that's, of course, because in Europe today, most of our products are made outside of Europe. And if the product is not made outside of Europe, the raw materials, the aluminum, the steel, the concrete, and so on, are made outside of Europe. And so when we look at European energy production, we only see the tip of the iceberg, which is these energy forms up here, but we don't see all of this down here, which is what makes the world move around or makes the world run. And one of the reasons that some countries have access to more fossil fuels than others. For example, the oil states in the Middle East has access to lots of oil and coal and so on, and China and India has access to lots of coal. And that's why those countries make the type of products they make, is because of what type of energy they have access to. So I just thought I wanted to share that with the audience. I also have other slides if we need to look at that.
The energy, if it's going to increase 10 times, then clearly we can see that increase. Is it going to come from nuclear as our discussion? So yeah, it really helps for the audience to picture it. So thanks for sharing that. There are two segments I want us to explore, perhaps how the energy price plays into the global inequality and economic volatility. So, for example, in the UK or other parts of the world where the more they were pushing towards the renewable energy, which is good, the energy prices went up, which was counterintuitive. And if the energy prices goes up, it hits into the pockets of people. So even though there may be people wanting renewable energy, but then that plays into that political football or political game of, oh, the more you have renewable energy, it makes your energy price goes up. But that's more due to policy. So having shared those contexts, what you think about the energy price and the economic volatility more from the individual pocket perspective?
Yes. And honestly, that's also part of the reason why we started our company. I mean, we saw this happening. Since I was a boy, when I was a boy, a lot of the products that we consumed in Denmark was actually made either in Denmark or in Europe. And I've seen over the 3 or 4 decades that more and more products were produced elsewhere outside of Europe. And a lot of factories were closed down. But Denmark have been in a unique situation that we have been able to still create a lot of jobs in the pharmaceutical industry and medical industry. The economic didn't sort of crash while we transitioned away from those sectors that use a lot of energy, like I talked about steel and aluminum factories. We used to have those when I was a kid, but we don't have those anymore because the electricity is way too expensive to make those products here. And part of the reason why the electricity is expensive is because we have a lot of wind and solar. But there's also another fun part, is that Denmark shipped out all these production companies or production of all the products to other places. And this means that today we use less electricity than some other countries. And we say that our politicians say we are very efficient. We were able to cut down. But of course, we still use the products. It's just the energy for those products are are consumed in India and China, and we don't talk about that. And then we install a lot of wind power in Denmark, and wind is intermittent, so some days the wind are blowing and other days it's not. But we were very lucky that we could hook up to the Norwegian and Swedish grid. And the Swedish and Norwegian grids are very unique because they have a lot of hydropower that you can easily turn on and off. So whenever the wind is not blowing, Sweden and Norway just turn up a little bit their hydropower, and Sweden has nuclear power as well, so they can also turn that up a little bit. So Denmark was in a unique situation where we could just ask our neighbors to give us more electricity when the wind is not blowing. And there's not many countries in the world that are in a situation like that. So that's quite unique. And I think that's why we have managed to install quite a lot of wind power without hurting our economy. And you cannot expect, most other countries in the world will not be able to do that. And we saw that. I saw that growing up when I was a young man and so on. And I think this was a bad solution for, at least for the rest of the world. And then we stumble on this Thorium energy that is really a game changer, because you can make energy at much lower cost than from fossil fuels or wind or solar or even fusion. A lot of times we talk about fusion in the future, but I actually wanted to start a fusion company or get involved in one of the fusion companies 20 years ago. But after studying it, I realized this was not the best idea, at least not for me. I mean, I love that other people are trying to make it work. But now I know that this Thorium energy that we are making can make energy at much lower cost than fusion ever will. And so that gives me a lot of hope. And that's also part of the reason why I believe that we will supply half of all the world's energy in 75 years from now. When I say we, it's not our company. There will be more companies, of course, making this type of energy. So there will be a whole host of companies. And I think big countries like India and China and maybe Russia and so on, they will probably make a state sponsored or state-owned enterprises who make Thorium energy. And those are big countries. India is the country in the world with the most people, and Africa is the continent with the most people. So yeah, let's see how it all plays out. But I imagine that those big countries and also Africa will install huge amount of energy in the next 3-4 decades.
So the area is a lot of talk about the safety aspect of nuclear. So I think it would be good to address that. I know the thorium, there are other types of the nuclear. I'm happy for you to show the differences, but how do you address all the safety concerns that has been talked about through the thorium system?
Yeah. So yes. So there's a lot of talk about molten salt reactors. This is the type of reactor we use for generating Thorium energy. There's a lot of talk on the internet about molten salt reactors being more safe than traditional reactors, and that is somewhat correct. I mean, it has some safety aspects that are better than old reactors, but I think the important message here is not that it's a little bit safer. The important message is that we have been misinformed for decades by the public media about how dangerous different types of energy sources are. It's absolutely true that the media has been telling us and the politicians have been telling us that nuclear energy is dangerous. That is a fact, and they've been talking about this for 40 years now. But it's not true. I mean, it's not true that nuclear energy is dangerous. So, but 99% of all people in society, they agree that this is true because that's what they've been told for 4 decades. But it's not true. So, if you look at, there was an accident in Japan like 15 years ago, Fukushima, and nobody died during the accident itself. There was one guy who volunteered to go into a room where it was quite high levels of radiation. He was working at the plant, and he volunteered to go in there and turn on a valve. And he knew that there was high radiation, but he still volunteered. He was quite old. And then some years later, 10 years later, he died from cancer. And people have agreed that there was a high likelihood that the reason he died of cancer was because he went into that room. So the world has agreed that the one person died from that accident. But then the authorities and the Japanese authorities they got afraid when that accident happened, and they decided to evacuate 150,000 people. And unfortunately, more than 2,000 people had died from this evacuation. So they didn't die from radiation; they died from the evacuation, and that's very unfortunate. And I think all nuclear experts agree that in the heat of the moment, maybe it was the correct thing to evacuate those people because they didn't know how much radiation there was and so on. But then a week later, when they had the measurements and they knew that it was not dangerous, those people should have been allowed to return. I mean, let's say maybe 10 people would have died from radiation when they were allowed to return. But now instead, because they were evacuated and they were not allowed to return, then 2,000 people died from all kinds of things like having their whole life upended. Some took suicide. Other people started drinking and died from alcoholism. I mean, even some people died in traffic accidents when they were evacuated because they got afraid and they drove their car too fast and died in that. So it's a very unfortunate example of how the politicians and the media scared people so much that people died from that scare. If you say, one person died from radiation and 2,000 people died from the media and the politicians, I think this is something we need to talk about. And of course, the media and politicians don't want to talk about it because it's not a good story for them. But it is quite painful as an industry to look at that, how everything was done in a wrong way and therefore people died. And I have another small anecdote to go with that. There was this Chernobyl reactor that also had an accident in 1986. And because of that Chernobyl accident, a lot of other reactors were not built. And there's actually still 8 of those types of reactors, the same type of reactor as the Chernobyl reactor running now 40 years later. And those reactors are still producing energy every day and they haven't killed anyone at all. I agree that those reactors are not the safest nuclear reactor design. It's actually, I think all people in the nuclear industry agree that those are the most unsafe reactors. But we also have to recognize that those 8 reactors ran for 40 years and they haven't killed anyone. But at the same time, for most countries, the alternative is to install coal-fired power plants. And every coal-fired power plant in the whole world, including in Europe and the US, kills people every year because of coal pollution and mining and so on. So even the worst nuclear power plant designs have not killed anyone in 40 years, but all the coal-fired power plants in the whole world kills millions of people. It's more than 1 million people that die every year from coal-fired power plants. So I think as an alternative, I mean, I would definitely choose any type of nuclear reactor over any type of coal-fired power plant if we're talking about safety. And yes, our type of reactors, these molten salt reactors we talked about, they are safer than the Chernobyl reactor. But the really big step is not so much making reactors safer. It's making sure that the politicians and media and authorities doesn't make bad decisions when there's an accident. It's also to make sure most people in the nuclear industry that die, they actually die in the mining part of the industry. So it's not the radiation from the reactors, it's in the mining when you have to mine for uranium. And I think we can make that part of the industry safer, and that will help all the reactors, not only our reactor, but all the reactors will, that whole industry will have less casualties if we focus on making the mining more safe. And of course, if we try to make mining of uranium more safe, this will also have an impact on mining all kinds of other materials. I mean, iron ore or coal or other things. And unfortunately, also quite a lot of people die in the mining of coal and iron ore and aluminum and copper and all these things. So I think this is where we should spend our focus on trying to understand how is it actually that people die in those industries. In wind and solar, there's a lot of people who die from falling down from roofs or falling down from wind turbines. And maybe we can do something about that. It's not so much something that I have to work on, but that industry should take a hard look at that and see if they can make it safer.
Yeah, that's again, it's good to have the insight explanation and to address it. And I believe the addressing is a very good part of the education, because we've seen that the media and the competitors, if I may use that term, it's not in their interest to explain it. And so, yeah, perhaps we need more of these discussions. So if our listeners, maybe there is an energy investor or a policymaker or simply someone who's passionate about sustainable transformation, what's your final thought for them?
Yes. So first of all, I mean, they can learn more about our company if they go to our website. It's called CopenhagenAtomics.com. We also have a YouTube channel where there's a lot of our podcasts or videos that we've done in the past that are explaining how this technology works and some of these other aspects around energy that we talked about in this podcast. And I also encourage people to just ask, ChatGPT or whatever their favorite AI is, because now with those AIs, it's actually much more easy for normal people without special education to teach themselves about how everything works, and they can ask questions like, do electrical vehicle use more energy than a gasoline vehicle? Or they can ask, how much energy does my Nike shoes use, and do they use that energy in China or in India or in Europe? And does it use the energy from the mining or for the transportation on the ships that bring the shoes to the store? So you can ask all kinds of questions and get sort of reasonably good answers. And I think this is brilliant, because in the past, if you were a student, like a high school student, and you asked your teacher about it, they didn't have a clue about it. They didn't know. So what were you to do? I mean, it was difficult for a high school student in the past to get that information. Maybe they had an uncle who was an engineer that they could ask, but now they can ask ChatGPT on their phone when they're sitting at a bus stop. I think that's brilliant.
Huge thank you to Thomas for these incredible insights. And I encourage the listeners to follow their journey at the Copenhagen Atomics and be part of a future where clean, safe, and affordable energy is not a dream, but is being engineered. Thank you so much, Thomas.
Thank you. Have a great day.